All right, so today we're going to do something kind of cool. We're going to find the absolute perfect plan to solve a tricky problem, and then we're going to try and break it. Now, you might be asking, why would we do that? Well, it's simple. The only way to know if a plan is truly great is to see how much pressure it can take before it cracks. So, put yourself in this situation. You've got a limited amount of time, a limited pile of materials, maybe a limited budget, and your goal is crystal clear: make as much profit as possible. The thing is, there are a million different ways you could combine everything. So how on earth do you find that one single, absolute best way to do it? To figure this out, we're going to dive into a case study about a company called Flair Furniture. They use this really powerful mathematical tool. It's called linear programming, to basically sift through all that noise and pinpoint the single most profitable plan for making their products. Okay, so here's the puzzle laid out for us. Flair Furniture makes two things: tables and chairs. Each one has to go through two departments: carpentry and then painting. But, and this is a big but, they've got some hard limits. They only have 240 hours of carpentry time available and just 100 hours for painting. The whole goal? Maximize profit. Tables bring in $70 and chairs bring in $50. Classic problem, right? So you plug all of that into a linear programming model, it crunches all the numbers, and bam! It spits out the perfect answer. The sweet spot is to make exactly 30 tables and 40 chairs. This is the one magic combination that uses their limited hours in the absolute best way to make the most money. And here is the big payoff. By sticking to that perfect plan, Flair Furniture can hit a maximum profit of $4,100. That's a solid, satisfying number. Problem solved, we can all go home, right? Well, not so fast. Because, let's be real, the real world is messy. It doesn't care about our perfect spreadsheet. Prices drop, people call in sick, new trends pop up. A plan that looks invincible on paper can completely fall apart the second it touches reality. So the real question isn't just what's the best plan, it's how tough is that plan?
Like, what if a new competitor shows up and you have to slash your prices? Does making 30 tables still make any sense if they're suddenly way less profitable?
Or what if your best carpenter calls in sick for a week? All of a sudden, those 240 hours of carpentry time? Poof, they're gone. The entire foundation of your perfect plan is just wrong. Now what do you do? And what if some new design trend hits and suddenly everyone wants chairs? Your model was built on one set of numbers, but the market is screaming for something totally different. Is your plan going to bend or is it going to break? All these what-ifs, they're the things that can destroy an otherwise perfect solution. Okay, so this is where things get really interesting. To handle all this uncertainty, we use a technique that's designed to poke, prod, and push on our perfect plan just to see where its breaking points are. And it has a name: sensitivity analysis. Yeah, think of it exactly like a stress test for your business plan. It lets us answer all those what-if questions with actual hard numbers. It'll tell you precisely how much the profit on a table can drop or how many carpentry hours you can lose before that perfect plan of 30 tables and 40 chairs is suddenly not so perfect anymore. So how does it actually work? Well, it's kind of broken down into three main things we look at. First, you analyze the profits. How much can our profit margins change before we need a new plan? Second, we look at our resources. How much can our available hours go up or down? And finally, there's this really cool thing called the shadow price. It's like a secret number that tells you exactly how much one extra hour of work is worth in pure profit. It's awesome for finding your biggest bottlenecks. Okay, but before we can really test those limits, we need a way to talk about leftovers. Because in any production plan, especially one that isn't perfectly optimized, you're going to have some stuff left over. And these leftovers have specific names: slack and surplus. And it's actually super simple to tell them apart. Slack is all about the resources you could have used but didn't. You had 100 hours of painting time but only used 80, that's 20 hours of slack. Surplus, on the other hand, is when you make more than a minimum target. If you promised a client at least 50 chairs and you ended up making 55, you've got a surplus of 5 chairs. Simple as that. Let's make this real. Imagine management just throws the perfect plan out the window and says, nah, let's just make 20 tables and 25 chairs. You run the numbers and, whoa, you're left with 85 unused hours in carpentry and 35 in painting. That is a ton of slack. Now, you could see that as wasted time, but it's also an opportunity, right? It means you have the flexibility to maybe take on a last-minute custom order. And if they had a minimum goal of making 42 items total, making 45 gives them a surplus of 3.
This is why knowing your slack and surplus is so important. It shows you exactly where the wiggle room is and where the waste is.
All right, so far we've been looking at plans that actually work, even if they aren't the absolute best. But sometimes the issue isn't the plan, it's the problem itself. Linear programming is a fantastic tool, but it's not magic. If you feed it bad info or contradictory rules, you can get some really, really weird results.
One of those weird results is called no feasible solution. This is basically when the math just throws its hands up and says, nope, what you're asking for is literally impossible. It happens when your rules contradict each other. It's like saying, we have to make more than 100 widgets, but also, we only have enough material to make 50. See, the rules just can't both be true. There's no solution.
The other strange case is even wilder. It's called unboundedness. This is when the model tells you, you can make infinite money. Now, as amazing as that sounds, it is always a giant red flag that you've made a mistake. It means you forgot to add a constraint. Maybe you forgot to put a limit on how many chairs people will actually buy. In the real world, you can't have infinite profit. So if your model says you can, you know you need to go back and fix your setup.
So what's the big takeaway from all of this? That perfect plan we found at the beginning, the 30 tables and 40 chairs, that's not the finish line. It's really just the starting pistol. The real strategy, the robust, smart strategy, comes from understanding how much you can push and pull and stress that plan before it finally breaks. It's all about knowing your boundaries. And that brings us to one final thought, a question for you. This way of thinking doesn't just apply to making furniture. It applies to pretty much any decision you have to make with limited resources. So think about it for your own work, or your studies, or any project you're working on. What's your perfect plan? And more importantly, what are the what-ifs you really need to test? Because finding those weak spots, that's how you build a plan that doesn't just work on paper, but actually survives in the real world.